Hey curious, this is Utsav Mandal and today we'll be discussing about magnetism in permanent magnets. So if you have seen my previous video which is about magnetism in current carrying conductors or the moving charge, then you must have noticed that I said that it's very spooky to say that magnetism is there in the first place, is already there, and it's very much linked with the quantum mechanics. uh, whenever we see quantum mechanics, we go complex and complex and complex, but in today's video we will be uh, explaining that how does magnetism work in the permanent magnet with some sort of simplicity. And here we go. Permanent magnets, they are simple or complicated? Well, charge, mass, energy, magnetism, these are the basic property, right? Magnetism? Well, you said that in previous video, the magnetism is an amended form of the electricity. So how could magnetism be the general property of a body? Well, electricity and magnetism are both linked and are the forms of energy and are interchangeable. And asking the question that why a body has magnetic property from the starting is like asking why a body is charged, or why a body has a mass, or why a body has energy. The answer is we still don't know. Atom is a nucleus, a positively charged nucleus having electrons revolving around it, uh, zigzag. You measure that the electrons, because they are moving, they form a current, and that's the magnetic field, and that's the reason why permanent magnets show magnetism. Well, that's not wrong, but it's also not totally correct. uh, it uh, it says that when many electrons are moving, there are spins, some in positive spin, some are in negative spin, so the total magnetic field created by the whole of an atom is zero. So how does it works? It is called as the orbital magnetic field. Now you may ask that if the atoms of a body already has the magnetic property from the, so why we say that only iron, nickel, cobalt and manganese, these are magnetic, and not why not me, why not you are magnetic? Well, it has a simple reason. The iron, nickel, cobalt, chromium, these have half filled cells. Half filled cells are the cells in which they are singly filled, which means that the electrons are moving in a single spin, which means that the magnetic field is aligned in the same direction, and they all add to a same directional magnetic field. Well, then you will say that why not chromium? Whether we know that chromium is not ferromagnetic, but it has half-filled cells. Its cells are fively filled, and it could have more magnetic field than that of iron or nickel or cobalt. But here comes a new concept, the concept of magnetic domains. So magnetic domains are, you can say, a tiny magnets that makes the whole of the molecule of a bunch of atom, or a single atom, which makes the whole substance, and it's the domain which is responsible for that tiny magnetic quantum property, magnetism, to get amplified into such a big thing which could be physically seen in our day-to-day life. So magnetism is the amplification of a quantum criteria which could be physically seen. So here when we talk about the domains are aligned. If they are aligned in the same direction, then they all add their magnetic field, and thus the body is magnetic. And if they are one and other oppositely aligned, then they may not cause a magnetic field which may make it a paramagnetic or totally a diamagnetic substance. Well, then what is a ferromagnetic substance and how does it work? Why does this scissor doesn't show magnetic property? It is also iron, and the magnetized stone was also iron. So why doesn't the scissor show the magnetic field? So it's because it's ferromagnetic, but its domain are not arranged in a direction. So, but if we put a very strong magnetic field near it, then the domains will get aligned in a single direction and will show magnetic property. So we know that ferromagnetic are very much attractive when they are given a magnetic field. Paramagnetic are little attract, and the diamagnetic they repel. They do not attract, they repel. So here the question could be, can you explain the ferromagnetic, diamagnetic and paramagnetic? So it's basically the domains in the ferromagnetic which are already aligned and needs a little magnetic field, and in paramagnetic it's a little bit aligned and it needs a little more magnetic field to be showing that kind of magnetic nature, and in the case of diamagnetic it is not aligned. So when we subject it to a magnetic field according to the Lenz's law, thus it shows negative magnetic field which it repels. Well, then how does it makes a body paramagnetic or diamagnetic? So it's explained by a quantum theory called as the exchange coupling. About exchange coupling we will talk in another video. But if you haven't watched my previous video about how does a conductor having current in it so magnetic field, then go check down the description, click on the link, watch the video, like it, and also thanks for watching. Keep the curiosity alive. Thank you.